You're welcome on Talks Education, and we are continuing with our organic chemistry and looking at methods of preparation of alkanes. And one of the methods we said is reduction of alkenes to alkanes by addition of hydrogen in the presence of nickel catalyst at 150 degrees Celsius, form alkanes from alkenes. Second method was reduction of alkynes to form alkanes. And then we say this requires 2 moles of hydrogen because you are removing 2 pi bonds of alkynes until you form an alkane. So we need 2 moles of hydrogen, but still in the presence of nickel catalyst at 150 degrees Celsius. Then we also said that it's possible to use palladium or platinum catalyst, but this time the reaction takes place at room temperature. Then reaction number 3, or method number 3, we're looking at how to prepare alkanes, but this time from alkyl halides. And we have looked at part A, what was synthesis. Part B was the addition of concentrated hydrochloric acid in the presence of zinc. And then next was the addition of copper catalyst. And we're now going to part D, which we are calling reduction of alkyl halides by addition of lithium, aluminium, tetra, tetrahydride. And I said this hydride is negatively charged hydrogen. Negatively charged hydrogen, which carries a negative charge, and you said it is a nucleophile. So when we add this reagent to alkyl halides, it is able to reduce them, and then we obtain alkanes. That is strictly if added in the presence of dry ether. Dry ether is just like an activator of that reducing agent. So if we can react this alkyl halide with lithium, aluminium tetrahydride, and the presence of dry ether, then we shall be able to obtain R hydrogen. This R is alkyl group, and remember we said an alkyl group, the difference between alkyl group and alkane is that the alkyl group is 1 hydrogen less than the expected alkane. So when you give it the hydrogen that was lacking, then it becomes an alkane. So remember we said this R is alkyl group really, alkyl group. Now, we can look at a specified example that when we react CH3, CH2, chlorine, and reduce it by lithium, aluminium tetrahydride, in the presence of dry ether. The end product is CH3, CH3. This one we call it ethane by IUPAC name, and this is chloroethane. So we shall have prepared an alkane from alkyl halide. Another example could be if we react CH3, CH2, CH2, then Br. This is an alkyl halide called propane. If we reduce it using lithium, aluminium tetrahydride. The presence of dry ether, we should be able to form an alkane. Yeah, this was a method really of preparing alkanes from alkyl halides, and this is the propane, that is propane. Okay, we can proceed and look at part D. Now, that was part D. Then part E, we have a method which is called Correa-House synthesis. This is a synthesis that was discovered by Correa, and discovered it while in the house. And then after him, it was named as Correa-House synthesis. But it's all about addition. It is all about addition of organoculprit. Just addition of organoculprit to alkyl halides. Remember, we are preparing alkanes from alkyl halides. So when you add organoculprit, which is of the formula, of the general formula R, that's the general formula of organoculprit. It is added in the presence of wet ether. And if we don't write wet ether, we can say ether, this time at 0 degrees Celsius. And we expect that at 0 degrees Celsius, it will contain some water molecules. That's why it is also possible to call it simply wet ether. So if we can add this compound to an alkyl halide in the presence of wet ether, then we shall be able to convert it to become an alkane. Here, for example, if we have Rx reacting with the ether, we shall be able to get R1, then plus shall be able to obtain those products. And these ones, of course, are not our major concern, but our major concern is the alkane which has been produced. And then when we look at this compound, it is increasing the length of the carbon chain. It had 2 other groups, but now this alkane is having this 1 other group. So by all means, we have increased the chain by at least a carbon atom. Take an example. If we have CH3, CH2, this being bromine, plus CH3, 2, this is copper and lithium, in the presence of ether at 0 degrees Celsius. We shall first of all have these two carbon atoms, that is CH3, CH2. Then one of the methyls here replaces the halogen, and we have that. Then plus CH3, copper, then plus lithium bromide. So that is the method that would have helped us to prepare an alkane from an alkyl halide, and this is going to be called propane, while this is called bromo. while it is called propane. Bromoethane. So these are 2 carbons here, and these are 3 carbons here. So even the length of carbon chain has been increased by at least 1 carbon atom. And this method, we are saying, it is helping us to prepare alkanes as well as increase the length of carbon chain.